Ya.
نه
Era io ben giorno d'Italia dal pubblico, ma rientrava da
Disability.
la sorta di
Come yok. Abi по next peki. वालेकुम मुफ्ती साहब।
That's Assalamu alaikum. How are you?
I'm fine. आप कैसे हैं सर?
Thank you.
शुक्रिया सर, शॉर्ट नोटिस पे आपके।
Most welcome, Janab. We are with you.
तरह चल रहा है डेढ़ भाई रेडियो इसलिए परिस्थिति है
هذا بيعمل صبرك زبورة ما صبرك.
Okay, next question. Okay, calculate the size and scope of a sanitary fever, which is serving a population of 0.4 million. The water consumption is estimated to be 300 liters per capita day.
हैंड्स अपने करे सैनिटाइज।
Mufti Sahib.
That's Assalamu alaikum.
Walaikum salam. I think we should start now our session.
You're ready.
Bismillah ar-Rahman ar-Rahim. Starting with the name of Allah, who is most beneficent and merciful. Welcome and good morning. It's my pleasure to welcome all of you on behalf of Small and Medium Enterprises Development Authority. Today is our second live session on energy efficiency. And today our topic is energy efficiency resource assessment in marble and textile sector. Sir, there was some problem with the internet, and I'm very much thankful to Mr. Dr. Khan Mufti Saab and his team for their precious time in on urgent basis and short notice. I think without wasting our time, I would like to invite Dr. Khan Mufti to share his screen and start his presentations on training. Please, Dr. Khan Saab.
Right. Thank you, Hidayatullah Saab, for inviting us on this very interesting topic of training. So this is the schedule of today's training. We'll just start with a brief concept that what is energy efficiency resource assessment, right? And then we'll share two very good studies with you. One is energy efficiency resource assessment of marble sector by engineer Zaim, and then energy efficiency resource assessment of textile sector by engineer Faiz. And hopefully after this, you will get an idea that why shouldn't you carry out a resource assessment in your own sector, whichever factory you will. So, let me start the first topic. So, energy efficiency resource assessment. What is the meaning of this? And we are from Center for Industrial and Building Energy Audits, UET Peshawar. I'll request all the participants
to mute their microphone.
Right, that happens in Zoom meetings quite a lot. So this is a quick introduction of our team. We have civil engineers, electrical engineers, mechanical engineers, right, and all towards the common purpose of industrial and building energy audits. So we'll start with the quick Pakistan energy scenario and US energy Sankey diagram, and then we'll talk about the resource assessment. Some of the initial slides you might have seen in the previous presentation also, those of you who were there in the previous presentation, but today we'll look at it from a new angle, from the angle of resource assessment, right? So we had talked about this, that on the left-hand side, there are the resources, right? Nuclear, Pakistan is a hydro as a resource, natural gas as a resource, sometimes we import it also. Coal, we have a resource, sometimes we import it also, and so same story with crude oil. So on the left-hand side, you have the resources, and on the right-hand side, you have the utilization, commercial, like agriculture, domestic, industry, transport, right? So sources of energy and the consumption of energy, right? And if you just look at the electrical sector, I think this has the huge losses, generation losses, etc. And almost they say that 1/3 goes to final use. Similarly, there are losses at each point. So can we reduce these losses, right? So previously, energy efficiency was thought that you can apply on the right-hand side, right? So conduct an energy audit and see that where you can make savings in the commercial buildings, in the domestic sector. So energy efficiency was a concept on the demand side. This is where the demand of energy is being created. Now the concept says that whatever you save, you give it back as a resource. So now energy efficiency, along with your nuclear, hydel, natural gas, coal, and crude oil, you have another resource in Pakistan, right? Which is called energy efficiency. So how do we calculate this resource, right? Similarly for USA, with losses are there, but if you recover, then it becomes a resource, right? So can we reduce wasted energy, right? And we say that waste is not waste until it is wasted. So with all the other resources, if you want to generate electricity, energy efficiency is the cheapest. It will cost something, right? It will have some cost. For example, 0 to 5 cents per kilowatt hour. Others are all more expensive. So it's a low-hanging fruit. Even if you look at the levelized cost of electricity, energy efficiency is the lowest, right? Solar, yes, it's coming to the left. Solar every year, every month, it is reducing, right? But the other nuclear, gas cycle, etc. So if you're installing a power plant, then we'll say that energy efficiency is the cheapest option. And we say that a megawatt saved is a megawatt generated, right? Same thing about levelized cost of electricity, same graph expressed in a different manner. So this is the cents per kilowatt hour. So again, 0 to 5 cents per kilowatt hour. So this concept was initially floated by ACEEE, American Council for Energy Efficiency. And this is the US electricity generation by resource. So 27% of electricity US is coming from natural gas, 27% from coal, nuclear power, renewable, petroleum, and 18% is coming back from energy efficiency measures. So whatever they were consuming last year, by applying some measures, some energy efficiency measures, they can put that much back to the grid. Now, looking at 18%, you know, it's no small resource. It's not a resource to be neglected. So we also have this resource in Pakistan, but how to tap it, that is the topic of today's lecture. So now I think you're very clear with the concept of that energy efficiency measures, although applied on the demand side, but can be counted towards at the supply side. So energy efficiency is a resource, right? And world over, such energy efficiency resource assessment reports are being generated. So for the Oregon state, it's one of the states, 51 states of America. So they conduct a full that what amount of resources available. Just for example, in KP, you want to survey for oil, right? That how much oil is available underneath the ground. You want to survey for natural gas, right? Similarly, there has to be a survey that has to be conducted that how much energy efficiency measures are available. It's available right there where you are sitting, underneath your building, right? There's, I'll say that there's a well of oil, right? So अगर आप सबको कहें कि आपकी फैक्ट्री के नीचे एक तेल का कुआं है, तो आप सब उसको खोदने में लग जाएंगे, right? So that's what we have to do. That we have to first estimate that how much of this resource there is. How these figures are calculated, Engineer Zaim and Engineer Faiz will tell more, but this is again from the Oregon State study that how many megawatt hours are available, right? So the yellow line is the technical, right? Purely from mathematical calculations, right? Then which are achievable, that you can really do it, and then cost effective, achievable, economics and market potential, everything, but still it's a lot. So everything that is mathematically possible, sometimes it's not physically possible, but still what all is really possible in your world, there's a huge resource lying there and we have to tap it, right? So the resource assessment starts with measurement, and mostly these resource assessments will start from energy audits. So once you know that how much is there, and you can classify that, how much can be saved, right? So by these resource assessments, it's benefit to the country. A megawatt saved is a megawatt generated. The total carbon footprint will reduce, and it makes your industries more competitive globally. So today we start with this message that Pakistan should start its journey on energy efficiency resource assessment. It might be taking the first step, but you will never finish if you don't start. So with this very short introduction, without going into technical detail, because that's followed in the subsequent lectures, you are most welcome to ask general questions. And then we'll go into the detailed resource assessment of marble sector and textile sector. So, general questions about resource assessment, you are most welcome. क्वेश्चंस जो नहीं पूछे वो माइक म्यूट कर लें क्योंकि बैकग्राउंड नॉइज बहुत आ रही है. So I'll request everybody to please mute their mic. But if you want to ask a question, please raise your hand और हिदायत साहब आपको डायरेक्ट कर देंगे. There are no questions. If you want, we can go to the next part of the lecture. And I will request Engineer Zaim to please share his screen and talk about energy efficiency resource assessment in the marble sector. Right. So over to Engineer Zaim. Thank you. Zaim, mic unmute कर लें. Zaim, आवाज नहीं आ रही आपकी.
Can you hear me now, sir?
Yes, now we can hear you. बस थोड़ा सा ऊंचा बोलें. We can hear you. Over to you.
My name is Zaim Ahmed. Basically, I'm a mechanical engineer and I have done my master's in thermal system engineering. I have been working with the Center for Industrial and Building Energy Audit since 2018, and I have more than 2 years of industrial energy audits experience. Today, we will be talking about the energy efficiency resource assessment of the marble industry for Peshawar city. The outlines of this lecture will be introduction. We will talk about the literature review of the energy efficiency resource assessment, the importance of energy efficiency in the marble sector, the problems in the marble sector, the methodology of energy efficiency resource assessment, the different energy audits conducted for this study, and at the end we will be calculating the quantifying the energy efficiency resource assessment potential for the Peshawar sector, and we will be concluding this presentation at the last. So first of all, we will start from the introduction. The energy use of Pakistan can be divided into four major categories. Number one, transport. The number second, residential sector, the commercial sector, and the industrial sector. The energy mix of Pakistan shows that around 37.46% of the energy is consumed by the industrial sector. It means that a large portion, a large chunk of energy is being consumed by this sector. If we look at the table, the last row of the table shows the annual growth rate of the industrial sector in Pakistan. From 2012, it has been
Excuse me, Zain, we can't.
yeah, listed from 2012 to 2018, and it can be seen that the annual is on increasing.
Zain,
Ji, sir.
there is some noise in your voice. Can you switch off your fans or etc. something?
Ji, sir.
So please continue. Now you can continue, Zain.
जी सर, अभी आपको मेरी आवाज आ रही है?
Noise बहुत ज़्यादा है बैक साइड पे, पता नहीं क्या मसला
हेलो
है.
सर, अभी भी है नॉइज?
अभी क्लियर हो गया, प्लीज थोड़ा सा ऊंचा बोले तो क्लियर हो जाएगा सब कुछ.
जी सर. So we will continue with the presentation. Let's talk about the literature review. Can you please mute your microphone? Ji. So let us see the energy efficiency resource assessment study of the Oregon State, which was conducted by the ACEEE. Oregon State के different sectors को study किया गया for its energy usage, कि कहाँ पे energy efficiently use हो रही है और कहाँ पे energy का use जो है inefficient है. As a result of that study, कुछ energy conservation measures suggest किए गए in the agriculture sector, in the food sector, in the wood and production, etc. और हर एक सेक्टर में से एनर्जी एफिशिएंसी पोटेंशियल को क्वांटिफाई किया गया फॉर द नेक्स्ट 10 years एंड एज अ रिजल्ट ऑफ दैट यहाँ पे जो है एक पोटेंशियल कैलकुलेट हुआ 306 मेगावाट ऑफ electricity can be saved by implementing the energy conservation measures. So ये जो 306 megawatt of energy saved है, this is basically an energy resource जो कि हम कहीं और जो है यूटिलाइज कर सकते हैं. तो इसी कॉन्सेप्ट को लेके हम आगे चलेंगे. इंपॉर्टेंस ऑफ एनर्जी एफिशिएंसी इन मार्बल सेक्टर को फिर स्टडी करते हैं हम. First of all, a study was conducted by the State Bank of Pakistan on the marble sector, which reported that the exports from the July to September 2012 were US dollars of 12.5 millions. और इन एक्सपोर्ट्स में काफ़ी हद तक इंक्रीज आया from July to September 2014. It means that the marble industrial sector has a huge growth potential. मार्बल की जो मार्केट है पाकिस्तान में वो डिफरेंट सिटीज़ में एग्जिस्ट करती है, जिसे इस ग्राफ में प्लॉट किया गया है. कराची, फॉर कराची द कस्टमर प्रेजेंस इन पाकिस्तान एज कम्पेयर टू पाकिस्तान इज 25%. और अगर हम पिशावर में देखें तो पिशावर में ओनली जो है 4% ऑफ कस्टमर की प्रेजेंस एज कम्पेयर टू द ओवरऑल नेशन जो है पाई जाती है. सो अगर हम सिर्फ पिशावर के लिए भी एक एनर्जी एफिशिएंसी रिसोर्स असेसमेंट प्रोग्राम डिज़ाइन कर लेते हैं और इसे कैलकुलेट कर लेते हैं, it means that we can present a little picture of the energy savings in this sector. There are some issues with the marble industrial sector. Around 200 marble units in Karachi are running at half of their capacity, thus incurring a production loss of over 27 million PKR a day. और ये जो स्टडी है ये कंडक्ट की थी स्टेट बैंक ऑफ पाकिस्तान ने in 2014. The marble sector of Peshawar is also facing some power shortages. Due to the shortage of power in the peak hours of the marble sector of Peshawar, thus the Peshawar's industrial sector is also operating at almost half of its capacity, half of its actual capacity. So जो major two problems यहाँ पे quantify किए गए या list किए गए हैं, that are number one, a very inefficient use of energy is exercised in the marble industrial sector of Peshawar. Number second, there is a lack of energy efficiency study and measures in the marble industrial sector. जब तक आप कोई study conduct नहीं करेंगे तो आपको पता नहीं चलेगा कि किस sector में कितना potential present है. So यहाँ पे जो है एक study की बहुत ज़रूरत है in the energy efficiency. So हमने क्या किया, हमने एक study conduct की for the marble industrial sector of Peshawar. Marble industrial sector of Peshawar basically includes 315 marble units. और इस study के लिए जो methodology adopt की गई that is listed. The first step of the study was to identify the significant energy uses. कि marble industry में कौन कौन से ऐसे equipments हैं या machines हैं या appliances हैं जो ज़्यादा energy use करते हैं. सबसे पहले हमें उन equipments को या machines को identify करना था. The second step was a detailed energy audit of ASHRAE level 1 and ASHRAE level 2. फिर पूरे industrial sector में से कुछ samples लिए गए और उन samples का energy audit किया गया. The third step was to evaluate the cost and benefit of energy efficiency measures. अब as a result of detailed energy audit, कुछ energy conservation measures suggest किए गए और हर एक energy conservation measure का cost and benefit analysis किया गया in terms of the economic parameters. In the fourth step, can you hear me, sir?
Yes, Zain, there's a request from the audience to switch into English. There are some people who can understand only English. So please switch to English. Thank you.
All right. All right, sir. So in the fourth step, the different barriers and constraints to the implementation were assessed. For example, there are some market constraints. There can be some other constraints. So all of the barriers were assessed in the fourth step. In the fifth step, the energy resource potential from this program was quantified in terms of kilowatt hours and in terms of megawatt hours. So we can see the bigger picture. We will move towards the energy audits. We conducted the energy audits of sample industries. A few energy audits are presented here. The energy audit of marble industry number 1. This graph shows the energy consumption pattern of the industry for different months. The vertical axis shows the kilowatt hours consumption. So you can see that the energy consumption is varying for different months. Then we studied the electricity bills of the industry. After studying the bills of the industry, we identified that the industry is being charged for the low power factor penalty. Because the industry is being operated below the power factor of 0.85, so the industry will have to pay the penalty on this. So the industry wasn't even aware of the fact that they are being charged as a penalty on this power factor. So first step was we identified the low power factor penalty from the electricity bills. The current practices in the industry was that the average power factor of the facility was 0.81. The impact of this practice was that the facility was being charged for a penalty of 28,848 Pakistani rupees per year for this low power factor. So we recommended that the power factor of the industry should be increased to 0.95 by the installation of centralized capacitor banks, which were calculated to be 13 kVAR. And the impact of this energy conservation measure would be that the industry will save 28,848 pk per year by implementing this measure in the energy bills. As a result of power factor correction, the consumption of the reactive power would be decreased, as indicated by the pink line or purple line. So for this energy conservation measure, we calculated the economic terms. If we increase the power factor, we would save a total of 28,848 rupees. This investment will be of 25,000 rupees, and this investment will pay back in 10 months. The benefit to cost ratio for this investment comes out to be 9, and the internal rate of return was calculated to be 82%. The second energy conservation measure was to replace the inefficient motors with the highly efficient motors. So first of all, we calculated the efficiencies of all the motors operating in the industry. The efficiency is listed in the table. In the last column of the table, you can see that the efficiency is varying from 52 to 84%. So the below 70%, we recommend to replace the motor. The current practice in the industry was that the industry was operated by the motors of 52 to 84%. As a result of this low efficient motors, the energy consumption of the industry was increased. We recommended that some of the motors which are operating below 70% of efficiency should be replaced with the 95% premium class efficient motors. This energy conservation measure would impact a saving of 12,156 kilowatt hour per year. This graph shows the decreased consumption of power by replacing the low efficient motors with highly efficient ones.
Hello. Sorry. Can I ask a
The
question,
economics
please?
of the
Can I ask a question, please?
you can ask.
My name
Yes,
is
you can ask.
Muhammad Ali. My name is Muhammad Ali. Can you please tell me that how did you calculate the efficiency of motors? Can you hear me?
Right. I think Engineer Zaim will respond. If you can go to the previous slide, Engineer Zaim. Right. So, right. So they are asking that how did you calculate the electrical motor efficiency? So you can tell about the power quality analyzer, etc. So you can share the process with them. Over.
जी ज़हीम साहब,
we
आप बता
have
सकते हैं कि आपने मोटर की एफिशिएंसी कैसे कैलकुलेट की पावर एनालिसिस से? ये काइंडली तरफ बताइए.
Zaim is having voice problems, but I'll share. So we use the Fluke power quality analyzer, And besides reading the nameplate current, nameplate voltage, we take the measurements that how much actual current it is taking, how much actual voltage it's consuming, actual kilowatt. And then we first calculate the load factor, that whether the motor is running on 100% load, 75% load, etc. And then US Department of Energy has formulas that how can you depending on the load factor and the actual current measurements, how can you calculate that what efficiency it's running now as opposed to the nameplate efficiency. Over.
ठीक है जी जी, थैंक यू वेरी मच फॉर द आंसर. लेकिन लोड फैक्टर से मेरी आपकी मुराद मैकेनिकल लोड है, यानी उसमें कितना लोडिंग मैकेनिकल पड़ी हुई है, तो वो कैसे कैलकुलेट किया?
राइट, बिल्कुल ठीक. अच्छा, सो आई मस्ट एडमिट ये जो एफिशिएंसी जो है ये डिफरेंट आपको जगहों पे डिबेटेबल मिलेगी, राइट. इसके तो दो तरीके हैं, या तो आप मोटर क्वालिटी एनालाइजर जो है उसके अंदर एक एफिशिएंसी मोड है, वो कैलकुलेट करता है. अच्छा, अदरवाइज हम बेसिकली इलेक्ट्रिकल एफिशिएंसी देख रहे होते हैं, क्योंकि उधर टॉर्क तो हम नहीं देख रहे कि कितना कंज्यूम कर रहा है, राइट. सो लोड फैक्टर किस तरह है? आई थिंक इट्स मेजर्ड करंट मल्टीप्लाइड बाय मेजर्ड वोल्टेज डिवाइडेड बाय रेटेड करंट रेटेड वोल्टेज. तो उससे पता चलता है कि कितने परसेंट लोड उठा रहा है. और एफिशिएंसी के दो तीन डिफरेंट मेथड्स आपको मिलेंगे. यूएसडीवी पे कुछ और मिलेंगे, किसी और वेबसाइट पे डिफरेंट मिलेंगे, बट it's a debatable question. मैं समझ रहा हूँ आप क्या पूछ रहे हैं. So does that answer somewhat, Mohammad Ali sahab?
जी, absolutely. Thank you very much. Thank you.
Thank you. Over to Zaim.
Yes, sir. So the different economic parameters calculated for this ECM energy conservation measures are: if we invest on the German Siemens motors, if we replace the current motors with the German Siemens, so the initial investment will be around 1.5 million rupees. It will pay back in 9.2 years. The benefit to cost ratio will be 0.85, and the internal rate of return is around 1%. But if we invest in the Chinese Siemens, so the initial investment is around half of the investment compared to the German Siemens. It will pay back itself in 4.6 years, and the benefit to cost ratio is 1.7. The internal rate of return comes out to be 17%. Although 4.6 years is a huge payback period, but still the life of motors generally ranges around 10 years. So still we can invest in this ECM. This is the summary of the energy audit. Basically, three recommendations were presented. The number one was to improve the power factor. The second was to replace the low efficient motors with the premium class motors. And the third one was to shift from peak hours to off peak, because the industry is being charged an extra amount of rupees if it consumes the energy in the peak hours. Similarly, the energy audit of the second industry is presented in the table. For the same week, we have done around 10 to 15 energy audits for the whole program to calculate the resource from this industry. So the different energy audits are presented in the tables. This is for the industry 2, and this is for the industry 3. Now we will study the energy efficiency resource assessment for this sector. The program potential identified for the energy savings in marble sector of Peshawar consists of: number one, power factor correction; number second, use of premium efficient motors; number third, shifting from peak to off-peak hours. Average savings of the industry are calculated on the base of 18 samples. You can see we have just listed 3 industries, but it is actually calculated for 18 industries. The savings in kilowatt hour per month will be, for a single industry, it will be 1346 kilowatt hour per month. Savings will be 16,000, around 16,000 kilowatt hour per year for a single industry, and the industry can save up to 215,000 PKR per year. If we extrapolate these results for 315 marble units of Peshawar, so we see that the estimated consumption of 315 marble units per year are around 12 million kilowatt hours. And if we implement the different energy efficiency measures presented, before in my slides. So we can save around 5 million kilowatt hours of electricity per year, which is a huge figure. If we compare these ECMs in terms of costs, in terms of rupees, so the estimated consumption, yeah, or the estimated bills at the whole industrial cluster consisting of 315 units pay to the PESCO, Peshawar Electric Supply Company, is around 156 million rupees. If we replace the low efficient motors with the highly efficient motors, we can save up to 67 million rupees for this industrial sector. If we correct the power factor, so we can save around 6.74 million Pakistani rupees per year. And if we shift the working hours from peak to off peak, so we would save around an estimated amount of 7.27 million Pakistani rupees per year. This table shows the tariff charge for different industrial units. Our industry of the marble sector lies in the category of B2B. So the industry is charged at different rates for different peak and off-peak hours. The conclusion of this whole study is that a saving of, in the power factor correction, we can save 6.7 million rupees with the initial investment of 5.25 million rupees. In the payback of this investment for the power factor correction will be 0.8 years for the whole industrial cluster of Peshawar. For the second ECM, we can save around 67 million rupees with an initial investment of 283.6 million PKR, and this investment will pay back in 4.2 years. Now for the third ECM, we can save around 7.2 million rupees, and this ECM will not cost any penny to the industry. From the overall program, we could save around 81.94 million Pakistani rupees for a period of 10 years. But we can save this rupees for a period of 10 years with one-time initial investment of 288 million Pakistani rupees. The whole investment in the three ECMs will pay back in 3.5 years. For recommendations and future work, there are worldwide government interventions to implement the energy efficiency programs. In Pakistan, NECA, the National Energy Efficiency and Conservation Energy Agency and Conservation Agency, should play its role for the implementation of programs like these. A study on energy efficiency resource assessment on marble sector for the whole Pakistan could help in presenting the bigger picture of the energy savings. Thank you from my side. If you have any questions, you can ask.
Assalamu alaikum. Fahad Salim, ज़हीम साहब, फहद सलीम मेरा नाम है. मुझे एक क्वेश्चंस पूछने थे, उसमें एक ये रिलेटेड था, यानी हम लोगों ने जस्ट कैलकुलेट एनर्जी ऑडिट, हम लोगों ने इस वक्त सिर्फ दो फैक्टर्स को कैलकुलेट किया, यानी कि हमने सिर्फ मोटर्स के ऊपर लोड देखा और उसके अलावा पावर फैक्टर को देखा. यही आई थिंक मुझे जो समझ में आया इसके एतबार से. और हमने क्या उनकी मशीनरीज वगैरह की भी इम्प्रूवमेंट के ऊपर हम उसके ऊपर फोकस किया जा सकता है?
जी, वहाँ पे भी फोकस किया जा सकता है. लोकल अगर आप एक मशीन की इंडिविजुअल बात करें तो फॉर ईच मशीन यू कैन स्टडी डिफरेंट पैरामीटर्स लाइक हार्मोनिक्स, and you can also study the power factor of each and individual motor by using energy analyzer. So ये जो पूरी स्टडी है जिस पे हमने बेस किया है, हमने ओवरऑल कंजम्पशन पे बेस किया है. हमने अपने एनालाइजर्स जो है मेन पैनल्स पे कनेक्ट किए थे, और ये इंडिविजुअल मोटर्स के लिए भी हो सकते हैं.
यानी ज़हीम साहब, एक चीज से मैं क्लैरिटी है ना, जस्ट क्लैरिटी कि हमने एक तो ना हमने ओवरऑल मेन सिस्टम के ऊपर लगा के हमने पावर एनालाइजर है ना से हमने एक तो कैलकुलेट कर लिया कि इनका एक्चुअल लोड क्या है और उसके अलावा इनका एफिशिएंट लोड क्या हो सकता है. यही आप कहना चाह रहे हैं?
नहीं, मैं सिर्फ पावर फैक्टर की बात कर रहा हूँ. फॉर पावर फैक्टर हमने पावर फैक्टर एज अ होल कैलकुलेट किया था फॉर द इंडस्ट्री, नॉट फॉर ईच एंड एवरी मशीन.
बिल्कुल
अब
बिल्कुल ज़हीम
दूसरा
साहब।
आपका जो दूसरा पॉइंट है एफिशिएंसी, जी जो दूसरा आपका एफिशिएंसी का पॉइंट है, वो हमने हर एक मशीन पे अलग अलग से लगा के रीडिंग्स ली थी फॉर ईच मोटर्स जो है इस मार्बल इंडस्ट्री में फ्रॉम 20 किलोवाट टू 50 to 60 किलोवाट तक रेंज करती हैं। तो हर एक मोटर के लिए हमने अलग से स्टडी की, उसमें से कुछ मोटर्स की एफिशिएंसी नॉर्मल थी इन द रिकमेंडेड रेंज, लेकिन ज़्यादातर जो मोटर्स थी वो इनएफिशिएंट चल रही थी, बिलो 70%, अराउंड 50%। सो वी रिकमेंडेड टू रिप्लेस द लो एफिशिएंट मोटर्स, क्योंकि ये जो इंडस्ट्री है ये बेसिकली सेकंड हैंड मोटर्स परचेज करती है टू सेव इट्स इनिशियल इन्वेस्टमेंट, लेकिन फिर उसकी कंजम्पशन को जो है ये लोग कंपेयर नहीं करते कि इसकी एट द एंड जो है आपके पास कंजम्पशन में कितना इजाफा होगा एज कम्पेयर टू द न्यूली परचेज मोटर।
ज़हीम साहब, जस्ट क्वेश्चन, थैंक यू वेरी मच, आपने बहुत अच्छा क्लैरिफाई कर दिया कि हमने मोटर्स को फोकस किया। मैं अपनी थिंकिंग के एतबार से सिर्फ जस्ट है ना, जस्ट फॉर माय थॉट्स कि मेरा ख्याल, यानी आपकी प्रेजेंटेशन से आई डिडंट विजिटेड एनी मार्बल इंडस्ट्री एट, तो मेरा ना ख्याल है कि हमारा यानी एनर्जी इंटेंसिव जो इंस्ट्रूमेंट है, इसका मतलब है वो मोटर्स हैं हमारे पास जो है ना एनर्जी इंटेंसिव है ना, वो होंगे। यानी कि अगर हमने मोटर्स को रिप्लेस कर दिया तो इनका मेन जो है ना एनर्जी की एफिशिएंसी को हम कंट्रोल कर सकते हैं। दूसरी चीजों को, दूसरे जो भी इंस्ट्रूमेंट्स वगैरह लगे हुए होंगे उनके ऊपर इतना ज्यादा फोकस करने की जरूरत इतनी नहीं होगी। जस्ट है ना, मैं अपनी क्लैरिफिकेशन के लिए कह रहा हूँ ज़हीम साहब।
जी जी, फर्स्ट जो हमारा
अच्छा
स्टेप
ज़हीम
होता है
सर,
वो यही होता है। जी लेट मी आंसर दिस प्लीज। फर्स्ट जो हमारा स्टेप होता है वो होता है आइडेंटिफिकेशन ऑफ सिग्निफिकेंट एनर्जी यूजेस, कि इस इंडस्ट्री में ज़्यादा एनर्जी कहाँ पे यूज़ हो रही है। सो इन केस ऑफ मार्बल इंडस्ट्री लाइटिंग का लोड बहुत कम है, द लोड ऑफ एयर कंडीशंस जो है बिल्कुल किसी इंडस्ट्री में है भी नहीं एयर कंडीशंस। द बेसिक लोड कम्स फ्रॉम द मशीन यूज फॉर कटिंग, पॉलिशिंग, रीसाइजिंग ऑफ द मार्बल। सो मेन जो लोड है इस केस में इलेक्ट्रिक मोटर्स हैं। अगर आप ये स्टडी किसी दूसरी इंडस्ट्री के लिए करते हैं, so the main load, yeah, significant energy uses can also include boilers, they can also include HVAC system. I hope this
बिल्कुल
answers your
बिल्कुल
question.
बिल्कुल 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 ज़हीम साहब, बेहतरीन हो गया। मैं असल में यही मैं कंफ्यूज कर रहा था कि क्योंकि बॉयलर्स वगैरह नहीं है हमारे पास, स्टीम का मेरा नहीं ख्याल है स्टीम की यहाँ पे यूसेज वगैरह होगी,
जी यहाँ पे
तो
यूजेज है नहीं।
बेहतरीन हो गया। ठीक है ज़हीम, थैंक यू वेरी मच ज़हीम साहब, थैंक यू वेरी मच।
अच्छा ज़हीम साहब, मेरा एक क्विक क्वेश्चन है। दिस इज मोहम्मद अली अगेन। आपने इनकी थर्मल इमेजिंग की, मोटर्स की थर्मल इमेजिंग की करने की कोशिश की?
जी फॉर फ्यू मोटर्स हमने थर्मल इमेजिंग की कोशिश की। सम मोटर्स वर इन द नॉर्मल ऑपरेटिंग अंडर नॉर्मल टेम्परेचर, और कुछ मोटर्स ऐसी थी जहाँ पे हमने थोड़ा सा टेम्परेचर इंक्रीज दे का नोटिस किया, लेकिन हमारा बेसिक फोकस जो है एफिशिएंसी और पावर फैक्टर, और ये जो थर्ड फैक्टर है शिफ्टिंग फ्रॉम पीक टू ऑफ पीक, इसी पे रहा फॉर दिस इंडस्ट्री।
अच्छा, थैंक यू।
Arfan sir.
Right, sir. You want to go to the next speaker?
No, it's our pleasure that one of the representative of Marble Association executive body member has joined us, and he would like to say something.
Wonderful, Janab. Most welcome.
So I will like, so now Mr. Imran Inam sir, please.
Rahim sir, please unshare your screen.
जी सर,
थैंक यू।
अच्छा जी, थैंक यू। अस्सलाम वालेकुम जी, थैंक यू वेरी मच। इरफान साहब आपके साथ भी था, और शायद ये जो स्टडी हुई थी इसमें से एक जो था हमारा यूनिट विजिट हुआ था जिसमें आए थे। फर्स्ट ऑफ ऑल वी आर रियली थैंकफुल और अप्रिशिएट भी करते हैं कि आप लोगों ने इसमें किया। थोड़ा सा इसमें ये था कि इसमें जो मतलब इनफैक्ट इट इज for your information, और बाकी भी colleagues who are working is energy audit या इस system में if they are working, तो मतलब but we want कि ये तो हमने support भी किया, हमने बताया भी, हमने सारी, क्योंकि बहुत लोग रेडी भी नहीं होते ऑडिट्स के लिए और उसके लोगों की अवेयरनेस और एजुकेशन की कमी है, मगर उसमें भी नेवर हार्ड बैक के मतलब अभी हम करें क्या, क्योंकि आई एम रियली रेडी कि मैं उस पर मतलब जो आपकी जो ऑडिट की रिकमेंडेशंस हैं उसको एडॉप्ट भी करें, बट स्टिल दिस इज अ टेक्निकल फील्ड, और हम क्योंकि मार्बल के उसमें सिंस 98 अभी तकरीबन ऑलमोस्ट 20 ईयर से हम ये काम कर रहे हैं मार्बल का। तो उसमें जो है थोड़ा सा आपकी उसके लिए ये करूं कि एक तो हमारे पास वी डोंट हैव ऑप्शंस, ठीक है जी। ऑप्शंस आपके पास होंगे, लोग करेंगे। फॉर एग्जांपल मैं आपको बताऊं, अभी हमारे पास लोड का इशू था, तो ये सारी फैक्ट्रीज जो थे, तकरीबन कोई 300 के करीब फैक्ट्रियां हैं जिन्होंने हु हैव कंट्रीब्यूटेड फ्रॉम देयर सेल्फ, और उन्होंने वहां पे ऑफ द रिकॉर्ड तकरीबन कोई 3.5 करोड़ रुपया अप्रोक्सीमेटली अप टू 3 लाख यूएस डॉलर जो थे दे हैव कलेक्टेड, और वो नाउ अभी एक अदर लाइन लाने के लिए कर रहे हैं। तो अगर इसमें हम थोड़ा सा एक्टिव हो जाएं और हम अल्टरनेटिव इसके साथ रिन्यूएबल और सोलर, जैसे पहले भी मैंने आपसे बात की थी कि अल्टरनेटिव जो आपका जो सिस्टम्स हैं या जो एनर्जी बोर्ड है, आई एम रेडी टू वॉलंटियर और मैं आपके साथ भाग दौड़ में। तो अगर हम कोई ऑप्शन इस तरह का दे दे लोगों को कि हम सोलर पे भी आ सकते हैं या हम इसको और वो कर सकते हैं, तो डेफिनेटली पीपल वुड लव। मगर उसके लिए शुरू में आपने एक केस स्टडी बनानी है, फॉर दैट आई एम रेडी। इसके साथ जो था, इसके साथ कुछ और जो इश्यूज थे जो मेजर, क्योंकि आपकी ये जो है कि समटाइम्स ठीक है वो पीक और ऑफ पीक पर है, पेनल्टी का लोड भी लगता है, वो भी बिल्कुल है, पावर पेनल्टी जो है। मगर उसमें एक ये है कि समटाइम्स कोई पत्थर जो है वो मिनरल जो है उसकी वो हार्डनेस ज्यादा होती है, उस वजह से भी वो मशीन जो है आपकी प्रोडक्शन भी कम देती है, और उस वजह से भी आपका वो जो है एमडीआई जो रीडिंग है वो ऊपर चली जाती है। तो इसके साथ हमें मार्बल में एनर्जी के हवाले से, चूंकि हमारा एक बहुत बड़ा वेस्ट भी है, जो मैंने पहले भी आपसे गुजारिश की थी, जिसमें स्लरी हमारा, और वो भी उस वजह से हमारी, क्योंकि ये जो मशीनरी है, हमारी मशीनें पुरानी, हम फैसलाबाद से जो है मशीनें मंगवा रहे हैं, पुरानी सीमेंस की हैं। अभी जैसे इंजीनियर साहब ने बताया कि चाइनीज की सीमेंस जो है वो शायद उसको रिप्लेस करे, बट फॉर दैट वी नीड टेक्निकल इंफॉर्मेशन कि हम किस तरह करें। इसमें ये था कि, और हम वी वुड लव कि हम तो चाह रहे हैं कि हमारा बिल जो है इस वक्त, इफ आई एम पेइंग 1 लाख रुपए मंथ, तो मैं चाह रहा हूँ कि 80,000 रुपये आ जाए, क्योंकि वो 20,000 रुपये जो है वो हमें इसमें सेविंग होगी। तो अभी आपकी जो है वो बिल्कुल हम अप्रिशिएट करते हैं, और इस जूम मीटिंग का फायदा लेते हैं। एनी अदर कंपनी या ऑर्गेनाइजेशन या एसजीएस वो जो है चूंकि, और या जो है आपकी सब टीम बड़ी अच्छी काम कर रही है, तो हम रिक्वेस्ट करें कि आप दोबारा आएँ और हमें अभी कोई प्रैक्टिकल भी जो है वहाँ पे कोई मेजर्स करा के दें, कोई मतलब डोनर्स कोई उसके लिए मिल सकते हैं या कुछ मिल सकता है। हम अपने तरफ से भी बिल्कुल इक्विटी बेस पे कंट्रीब्यूट करने के लिए तैयार है, क्योंकि दिस इज आवर बिजनेस। हम वो वेलफेयर के अप्रोच पे नहीं जाना चाह रहे। थैंक यू वेरी मच इरफान साहब।
थैंक यू इमरान साहब। मुझे याद पड़ता है आप चंद साल पहले ऑफिस आए थे और वहां से हमारा रिलेशनशिप स्टार्ट हुआ। टू आंसर ऑल 3 क्वेश्चंस, यस, दिस वीक इटसेल्फ मैं इंजीनियर ज़हीम साहब से रिक्वेस्ट करता हूं कि आपके साथ एक एक्सक्लूसिव बेशक जूम मीटिंग या रियल मीटिंग अरेंज करते हैं, और अब इम्प्लीमेंट करने के लिए क्या करना है उसमें हम आपको हेल्प करते हैं। और इवन आपको पता है इट्स पार्ट ऑफ यूनिडो प्रोजेक्ट भी चल रहा है, उनसे भी हम बात कर सकते हैं आगे फाइनेंसिंग के लिए। और जो सोलर की आपने बात की, इन दैट आल्सो वी कैन हेल्प। इन तीनों आइटम्स पे आई थिंक वील हैव अ सेपरेट मीटिंग दिस वीक इटसेल्फ। आई विल रिक्वेस्ट इंजीनियर ज़हीम टू कॉल यू, और फिर हम तीनों साथ बैठ जाएंगे, चाहे जूम पे चाहे फिजिकली, और तीनों पे आगे चलते हैं। पहले जो रिपोर्ट है उसको इम्प्लीमेंट करना है मोटर्स में, सेकंड आपको अगर फाइनेंसेस में कोई हेल्प चाहिए, और थर्ड सोलर। ऑल 3 आइटम्स इंशाल्लाह। थैंक यू फॉर योर
सर, इसी मेरे जो यूनिडो को जो नेशनल प्रोजेक्ट कोऑर्डिनेटर है उनसे भी बात हुई है, उन्होंने कहा कि बिल्कुल हम इस पे वो करेंगे, और दैट्स क्रेडिट आल्सो गोज टू यू कि आपने हमें लिंक किया उनके साथ। तो इंशाल्लाह इस पे सर यू विल फाइंड अस वेरी एक्टिव सर। थैंक यू वेरी मच सर। बिल्कुल आप जब कहें, आई एम जस्ट फोन कॉल अवे सर।
थैंक यू इमरान साहब। ओवर टू हिदायत साहब।
थैंक यू इमरान साहब। अब अच्छा ज़हीम साहब, अब उज़ैर शहजाद साहब कुछ क्वेश्चन करना चाह रहे हैं, सो इट्स ओवर टू उज़ैर शहजाद साहब, प्लीज आस्क योर क्वेश्चन।
वालेकुम
मिस्टर उज़ैर साहब,
आवाज आ रही है सर?
आवाज आ रही है, लेकिन आपकी बैक साइड से शोर बहुत ज्यादा आ रही है।
अभी मेरे शायद अभी क्लियर है?
अभी क्लियर है। प्लीज आस्क योर क्वेश्चन बिकॉज़ वी आर रनिंग आउट ऑफ टाइम।
अच्छा सर,
Yes,
क्वेश्चन
we
ये है
can
कि
hear
हम
you.
अगर मोटर की शाफ्ट पे अगर कटर्स, नंबर ऑफ कटर इंक्रीज करते हैं, क्योंकि मैं मार्बल सेक्टर में डायरेक्टली इन हूँ और एनर्जी ऑडिट्स वगैरह भी किए हैं, हम लोगों ने स्टार्ट करने थे तो पेंडेमिक की वजह से कुछ डिले हो गए। तो नंबर ऑफ कटर्स मार्बल सेक्टर में ये जो ब्लेड्स लगाते हैं शाफ्ट पे, तो वो विदाउट एनी कैलकुलेशन लगा रहे होते हैं। उनकी वजह से जो मैंने रियलाइज किया तो उनकी मोटर्स की बर्निंग का जो रेशियो है वो ज्यादा है। और इनकी सारी जो मशीन्स हैं वो फैसलाबाद से आ रही होती हैं, जैसे कि सर ने कहा है, तो उस पे नेम प्लेट पे कोई चीज मेंशन नहीं है। पावर फैक्टर, किलोवाट चले हमें उनसे पता चल जाते हैं, लेकिन बर्निंग ज्यादा हो रही है। तो दूसरी चीज, इनकी कोई लोड लिस्ट नहीं है, मतलब लोड लिस्ट भी नहीं है, फिर प्रोडक्शन शीट भी नहीं है। हमें प्रोडक्शन शीट के लिए कुछ गाइडेंस चाहिए कि कैसे हम लोग प्रोडक्शन शीट और टोटल कंजम्पशन को अलाइन करें, ताकि हमें एक्चुअल प्रोडक्शन और कॉस्ट हमें पता चल सके। काइंडली इस पे हमें कुछ गाइड कर लें इधर।
जी, आपका क्वेश्चन जहाँ तक मैं समझ सका हूँ वो ये है कि सम ऑफ द मोटर्स इन द इंडस्ट्री आर ओवरसाइज्ड और अंडरसाइज्ड, क्योंकि साइजिंग का जो इनके पास कोई कैलकुलेशन नहीं है। क्या यही क्वेश्चन है आपका?
जी
और
बिल्कुल बिल्कुल सर।
जी, और दूसरा जो है आपका क्वेश्चन है कि मोटर्स पे जो है ये मोस्टली सेकंड हैंड मोटर्स होती हैं या आफ्टर यूजेज फॉर 3 to 5 years और अप टू 10 years उनके नेम प्लेट का डेटा भी हमारे पास नहीं होता, तो हाउ कैन वी
जी सर,
कैलकुलेट द एफिशिएंसी? ये आपका सेकंड क्वेश्चन है।
बिल्कुल। और थर्ड सर के, क्योंकि हम लोग जब तक हमें प्रोडक्शन शीट नहीं पता हो सकती उस वक्त तक हम पर स्क्वायर हम उसके पर पीस जो मार्बल का ये फिनिश करते हैं, तो उस पे हम कॉस्ट ऑफ इलेक्ट्रिसिटी नहीं निकाल सकते जब
बिल्कुल
तक इनकी प्रोडक्शन शीट ना हुई।
जी, यही
और
इशू
सर,
है मोस्ट ऑफ द मार्बल इंडस्ट्रीज में कि प्रोडक्शन जो है वो रिकॉर्ड में नहीं होती कि कितनी प्रोडक्शन है। फर्स्ट ऑफ
सर
ऑल आई वुड
दूसरा
लाइक टू
इन्हें,
आंसर योर फर्स्ट क्वेश्चन।
ओके सर।
जी, तो आपका जो फर्स्ट क्वेश्चन है कि मोस्ट ऑफ द मोटर्स आर ओवरसाइज्ड और अंडरसाइज्ड, तो उसके लिए हमें फिर से वही एनालाइजर लगा के कैलकुलेशंस करनी पड़ेंगी फॉर ईच मोटर्स। सपोज आपकी इंडस्ट्री में 20 किलोवाट का एक मोटर या एक मोटर लगी हुई है, तो आप उसके साथ अपना पावर क्वालिटी एनालाइजर कनेक्ट करेंगे और एंड विद द हेल्प ऑफ सम बेसिक फार्मूलाज यू विल गेट द लोड फैक्टर फॉर दैट। आप जो है अपनी मोटर को एक दिन या 2 दिन ऑपरेट करें फॉर द सेम लोड जो इस पे स्टडी रहता है, और आप वो नोटिस करें कि आपका लोड फैक्टर फॉर 1 डे और 2 डे और फॉर 1 वीक कितना आ रहा है। इट शुड बी फ्रॉम 50 to 70%, नॉट बिलो देन दैट और नॉट अबव देन दैट। अगर ये इस रेंज में है लोड फैक्टर आपका, तो ये नॉर्मल और रिकमेंडेड रेंज है। लेकिन अगर आपकी मोटर बिलो 50% है, इट इज़ ऑपरेटिंग एट 30% लोड फैक्टर और 40% या 35%, सो इट मीन्स दैट आपकी जो मोटर है वो ओवर साइज है। ठीक है, तो यू शुड हैव टू चेंज द मोटर रेटिंग।
सर अगर स्टोन की हार्डनेस चेंज हो जाती है तो फिर ये फैक्टर तो वो अनसर्टेनिटी होगी ना सर, वो तो फिर हम कैलकुलेट नहीं कर सकते, क्योंकि यहाँ माइंड से डिफरेंट माइंड
जी
से स्टोन आ रहा होता है और यहाँ पे कोई
जी,
हार्डनेस
फॉर
चेक
दैट,
नहीं हो सकती।
जी जी, फॉर दैट पर्पस हमने 70% तक लिमिट रखी हुई है। ये जो
ओके ओके
70 से ऊपर है अप टू 100% ये जा सकती है। कुछ इवेंट्स पे या कुछ टाइम्स पे आपका लोड जो है 80 तक भी जा सकता है, 90 तक भी जा सकता है। फॉर दैट पर्पस आई एम सेइंग दैट आपकी जो मोटर है वो 50 to 70% जो है इसकी रेंज में होनी चाहिए इन द लोड फैक्टर, इन द रेंज ऑफ दिस लोड फैक्टर। अगर इससे ऊपर या नीचे है तो या ये ओवर साइज है या अंडर साइज है। ये आपके वो पहले क्वेश्चन का आंसर है। आपका
ओके
जो सेकंड क्वेश्चन था कि हमारे पास कोई टेबुलेटेड डेटा नहीं होता नेम प्लेट्स का, तो बेसिकली हमने भी कुछ जगहों पे ऐसा किया है कि जो मोटर्स थी, सपोज आपकी मोटर है वो 25 किलोवाट की है, इतना तो हर इंडस्ट्री के मैनेजर को पता होता है कि मेरी ये मोटर इतने किलोवाट की है या इतने हॉर्स पावर की है। सो जिस जिस केस में हमारे पास डेटा अवेलेबल नहीं था, हमने उसके मैन्युफैक्चरर की वेबसाइट सर्च की और उसी आरपीएम या उसी किलोवाट की मोटर के नेम प्लेट डेटा को वहाँ से कलेक्ट किया। या अगर आपको उसी मैन्युफैक्चरर का डेटा नहीं मिलता, तो आप किसी स्टैंडर्ड मैन्युफैक्चरर लाइक सीमेंस या दूसरी जो कंपनीज हैं उनके मोटर्स का डेटा लेके कैलकुलेशंस कर सकते हैं। द कैलकुलेशंस विल बी नॉट एक्यूरेट, लेकिन वो जो है अप्रॉक्सीमेट करेंगी आपके डेटा को। अभी आपको क्लैरिटी हो गई है?
जी जी बिल्कुल सर, ये क्लियर हो गया।
उज़ैर सर क्लियर हो गया। अच्छा, मेरे ख्याल में मदिहा नकवी साहब कुछ पूछना चाह रहे हैं, प्लीज आप पूछ लें अपना क्वेश्चन।
Can you hear me?
जी वालेकुम सलाम, I can hear you.
या वालेकुम सलाम, we can hear you.
सॉरी अगर मैं क्वेश्चन रिपीट कर रही हूँ, इंटरनेट डिस्कनेक्ट हो गया तो शायद मैं सुन नहीं पाई। तो ये पूछना था कि आपने जनरली जो डिस्कस किया वो मोटर की एफिशिएंसी वगैरह को डिस्कस किया, ठीक है, लेकिन उसको अगर ब्रॉड में देखें तो क्या लाइट वगैरह या क्या कौन सी ऐसी जनरल चीजें हैं जिनको हमें मद्देनजर रखना चाहिए?
आपकी आवाज कट रही है।
मार्बल
There is a noise in your voice. I cannot hear you.
आई थिंक जहां तक उनका क्वेश्चन मैं सुन चुका हूं, मैं रिपीट कर देता हूं. So she's asking that we have talked only about motor efficiency, but there are many other things that should be considered in a factory. For example, lighting and other things. So Engineer Zaim can reply to that. Over to Engineer Zaim.
जी सर, हाँ इस क्वेश्चन का आंसर आई थिंक मैं पहले भी दे चुका हूँ. ये जो इंडस्ट्री थी मार्बल इंडस्ट्री, इसमें सारी मशीन जो है इलेक्ट्रिक मशीन थी और इसमें जितने भी इक्विपमेंट्स लगे हुए थे वो बेसिकली मोटर्स पे ऑपरेट कर रहे थे. मोटर्स वर यूज फॉर फिटिंग, फॉर पॉलिशिंग, फॉर रीसाइजिंग. ये इन पर्पजेस के लिए सिर्फ मोटर्स लगी हुई थी. लाइटिंग का लोड कंपेरेबली बहुत कम था. इस इंडस्ट्री में कोई बॉयलर, कोई HVAC सिस्टम, कोई फर्नेस या कोई इस तरह का हीट रिकवरी सिस्टम इंस्टॉल्ड नहीं था. तो हमारा जो मेन फोकस है वो मोटर्स ही रहे. If we go for other industry like food industry, like cement industry या जो other industries हैं, steel industry, तो वहाँ पे आपको थर्मल लोड भी देखने होंगे. अब वहाँ पे आपको बॉयलर्स, वहाँ पे आपको फर्नेसेस की एफिशिएंसी, वहाँ पे आपको हीट रिकवरी सिस्टम में जो है इसकी इफेक्टिवनेस, ये सारे पैरामीटर्स. और इसमें अगर कहीं पे कोई गैप्स हैं तो उसमें भी हम एनर्जी कंजर्वेशन मेजर सजेस्ट कर सकते हैं. ये डिपेंड करेगी इंडस्ट्री टू इंडस्ट्री. ये जो इंडस्ट्री थी ये स्मॉल स्केल इंडस्ट्री थी, तो इस वजह से इसमें सिर्फ मोटर्स ही है. द मेन फोकस फॉर मोटर्स.
नेक्स्ट इज आमिर साहब. आमिर साहब आपने हैंड रेज किया हुआ है, प्लीज गो अहेड.
जी अस्सलाम वालेकुम. मेरा क्वेश्चन ये था कि रिसोर्स असेसमेंट के जैसे आपने ये लास्ट पे स्लाइड शेयर की हैं, तो ये सिर्फ पेशावर सेक्टर के लिए थी या इसको जो रिजल्ट एक्सट्रापोलेट हुए हैं ये इंटायर पाकिस्तान के लिए है?
ये
और
सिर्फ
दूसरा ये कि जी
पूछें. जी आमिर साहब आप पूछें.
जी दूसरा इसी से रिलेटेड क्वेश्चन था. जब आपने ये एक्स्ट्रापोलेट रिजल्ट किए हैं तो आपने ये 18 इंडस्ट्रीज को आगे फर्दर जितनी भी इंडस्ट्रीज हैं उस पर एक्स्ट्रापोलेट किया, तो आप इसमें कौन से फैक्टर्स कंसीडर किए, लाइक इंडस्ट्री का साइज भी, या फिर आपने जस्ट वो जो 18 का सैंपल है उसको जस्ट उसी को आगे विदाउट कंसीडरिंग अदर फैक्टर्स ऑफ अदर मार्बल इंडस्ट्री कि उसका साइज कितना है, प्रोडक्शन कितनी है, आपने उसको एक्स्ट्रापोलेट कर दिया?
जी सबसे पहले हमने ये पूरी असेसमेंट है ये सिर्फ पेशावर इंडस्ट्री सेक्टर, मार्बल इंडस्ट्री सेक्टर के लिए हमने की है, जिसमें कि 315 इंडस्ट्रियल यूनिट्स हैं. अब जो सैंपल साइज हमने लिया है उसको हमने 3 कैटेगरीज में डिवाइड किया था, जिसका मेन फैक्टर था द कंजम्पशन इन किलोवाट आवर्स, जिसकी कंजम्पशन 2000 किलोवाट आवर्स टू 3000 किलोवाट आवर्स में रेंज कर रही थी. वो एक हो गया हमारा सैंपल. दूसरी इंडस्ट्री का सैंपल फ्रॉम 3000.
सर आपकी आवाज़ बहुत कम आ रही है, बहुत थोड़ा सा ऊंची बोलेंगे.
Can you hear me now?
Yeah, now I can hear you.
जी पहले आपके क्वेश्चन का आंसर ये है कि ये पूरी जो असेसमेंट है ये सिर्फ पेशावर के मार्बल सेक्टर के लिए है, जिसमें कि 315 इंडस्ट्रियल यूनिट्स हैं. आपके सेकंड क्वेश्चन का आंसर ये है कि हमने जो 315 इंडस्ट्रीज हैं उन्हें 3 कैटेगरीज में क्लासिफाई किया अकॉर्डिंग टू द कंजम्पशन, एनर्जी कंजम्पशन, इलेक्ट्रिसिटी कंजम्पशन. और फिर हर एक कैटेगरी से हमने सैंपल्स कलेक्ट किए, 18 सैंपल्स, और फिर उनका जो हमने एक्सट्रापोलेशन की. तो यही टेक्निक हमने यूज़ की है. अब जितना आपका सैंपल साइज बढ़ता जाएगा उतनी आपकी कैलकुलेशन जो है एक्यूरेट होती जाएंगी. तो हम इतना ही कर सकते थे, हमने इतना ही किया है. अगर आप कहीं और किसी और जगह या किसी दूसरे सेक्टर की असेसमेंट करना चाहते हैं और मोर एक्यूरेट होना चाहते हैं तो आपको अपना सैंपल साइज बढ़ाना होगा.
Okay, got it. Thank you.
वेलकम. जी कोई और क्वेश्चन?
जी इसमें इजाजत है जी?
जी जी
इमरान साहब।
अच्छा अच्छा, थैंक यू। अच्छा सर, इस तरह है कि इसमें थोड़ा सा यहाँ पे एक और भी रिजवान साहब का भी क्वेश्चन आया है चैट पे कि प्रोडक्शन का रिकॉर्ड होता है वो इनफॉर्मल है, मतलब उसको आप, क्योंकि यहाँ पे हम जो आजकल, पहले हमारी जो था व्हेन वी हायर्ड लेबर सो वी पेड देम ऑन मंथली बेसिस, बट सिंस लॉग ये एक सबसे बड़ा, खासकर इरफान साहब के नॉलेज के लिए, क्योंकि ये जाहिर ही इज आवर एक्सपर्ट और सीनियर, इनका बड़ा नॉलेज है इसमें सर। ये सिंस लास्ट 3 to 4 years ये हुआ है कि जब एनर्जी का क्राइसिस आया तो इसकी वजह से लेबर को नाउ वी आर पेइंग ऑन पर स्क्वायर फीट, कि आप कितनी प्रोडक्शन करेंगे तो उसके बेस पे आपको पेमेंट होगी। तो उसका तो रिकॉर्ड हम रखते हैं, इसमें नो डाउट। वो इनफॉर्मल है क्योंकि जाहिर है नाउ वी आर पेइंग, क्योंकि ये भी सबसे बड़ा एक इंडिकेटर है हमारे एनर्जी क्राइसिस का, कि हमने अभी मंथली बेसिस पे नहीं करते। हम कहते हैं भाई आपने अगर 500 स्क्वायर फीट किया तो आपका 1.5 रुपए के हिसाब से मिसाल 700 रुपया हो गए। उसमें स्किल्ड और अनस्किल्ड और डिपेंड करता है कि कौन सी मशीन चला रहा है, कौन सी वो वर्टिकल चला रहा है, गैंगसा चला रहा है, पॉलिशर चला रहा है, हर एक का रेट अलग है। तो प्रोडक्शन का रिकॉर्ड होता है मगर वो थोड़ा सा इनफॉर्मल है। यही मैं कह रहा था कि इसमें हमें थोड़ी सी टेक्निकल उसकी है, और इस फायदा लेते हुए इस फोरम से एक और जो है इस वक्त सबसे बड़ा जो मार्बल में हम चाहेंगे कि यहाँ पे देयर इज नॉट अ सिंगल हैंडीक्राफ्ट यूनिट, और उस वो भी वेस्ट से ही बनेगा। और उसमें यह है कि जहाँ पे एक्सपोर्ट्स की बात हुई, स्टेट बैंक के साथ भी चूंकि मैं काम कर रहा हूँ और मार्बल सेक्टर में उनके लिए मैंने मुख्तलिफ सेशंस अवेयरनेस अरेंज किए, उनके साथ टाइम टू टाइम कामरान साहब के साथ उनके साथ बातचीत होती रहती है। तो उसमें भी हमें थोड़ा सा टेक्निकली वो चाहिए कि हम इसको किस तरीके से, मतलब अपने ये हैंडीक्राफ्ट और इसको, तो इसमें काम की बहुत ज़रूरत है। और इसने, और इस वक्त स्मेडा की भी स्टडी है, वर्ल्ड बैंक की ERK प्रोजेक्ट की भी स्टडी है कि सबसे ज्यादा एम्प्लॉयमेंट इस वक्त मार्बल सेक्टर ने जनरेट की है KP में और न्यूली मर्ज एरियाज में। तो ये इसके पोटेंशियल और स्कोप की बात है। थैंक यू सर।
इमरान साहब फॉर योर वेरी यूजफुल फीडबैक, और इंशाल्लाह आपके साथ लेके स्मीडा के साथ लेकर इसको आगे चलेंगे। सो आई थिंक इफ यू अलाउ विल मूव टू द नेक्स्ट स्पीकर, फिर आएंगे क्वेश्चन आंसर के ऊपर। सो थैंक यू इंजीनियर फॉर योर वेरी यूजफुल प्रेजेंटेशन। Next, I'll request Engineer Faiz to share his findings about the textile industry. Over to Engineer Faiz.
Assalamu alaikum.
Engineer Faiz, please share your screen. Please go ahead. And please give the presentation in English because our audience would rather prefer that. Thank you.
Okay. Assalamu alaikum. Can you see my slides, all of you?
Yes, please go ahead. Thank you.
Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Engineer Faizullah Khan from Center for Industrial and Building Energy Audit. I am an electrical engineer with MS in Energy Management and Sustainability, with prior experience of energy audits in different sectors within Pakistan of 2 years. The topic of today's lecture for this webinar is Energy Efficiency Resource Assessment of Textile Industry in Pakistan.
Dear Faiz, we'll just request you to speak a little louder. Mic के करीब बोलें और थोड़ा सा ऊंचा बोलें. Thank you.
Okay, noted, sir. Thank you. First, I wanted to consider that we should see that Pakistan energy mix. The slide you see that the major chunk we have see that natural gas and oil. For the demand side management and resource assessment of energy efficiency, we see that the major chunk we are using as energy resources natural gas and oil, which we are importing from other countries, which we, if saved this energy, we will save our imports. Okay, this slide, Zaim also shared this slide, and we see that the most consuming part of the energy consumption sector is industrial, preceding by transport. And we see that 37% of energy as of 2017 and 2018 Hydrocarbon Development Institute of Energy, according to Energy Engineer book, that 37% of energy has been used by industrial sector. So it is very important to cope this challenge and to be considered this. Okay. If we see the graph, we see that the major energy consuming industry in Pakistan is cement industry, followed by textile, which is 17%. So it means that the textile industry is consuming 17% of energy of the whole energy mix of the industrial sector. That is the major part of the energy mix of Pakistan. Okay, if we see the Pakistan textile industry, it is the most important industry within Pakistan, and it is the ranks 8 in the Asia on the list of textile commodities exporter. And textile in Pakistan contributes to 88.5% to the GDP of Pakistan, and its total export of the Pakistan textile is about 50%, and it provides employment to the 45% of the total labor force. And Pakistan is the 4th largest producer of cotton, as Pakistan is the agriculture country. And you can see all these figures that how textile industry is the important industry in Pakistan, as it is the one of the main industry who has the independent textile organization and textile ministry who are running this industry. There is no industry who has independent ministry. Textile is one of them. Okay, if we see the electricity and the thermal consumption, the energy consumption within textile industry, we see that the major textile, first to say that textile industry, we categorize that textile industry is categorized into different categories, that is spinning, weaving, composite mills, finishing, and stitching. All they have different SEUs, significant energy uses. If we considered spinning as into consideration, the main energy use, the main significant energy use in spinning sector is electrical energy. If we consider finishing or weaving, in finishing, the thermal energy use is the significant energy use. We can see the breakdown of the electrical and thermal energy use in the composite textile plant. It is actually the US study. In spinning sector, we see that the ring spinning and the humidification is the major change in energy consumer within the composite textile plant. And if we see in the if we see thermal energy consumption in textile plant, in composite textile plant, we see that boiler losses and humidification and steam distribution are the major chunk of energy consumption in that sector. Okay, there is some literature review all over the world, and within all over the world, and within the Pakistan sector that we have studied for this research. Energy cost is the next to raw material cost, and about 15 to 20% more than production cost. All of the maybe in our mind that that the major cost is the raw material and the labor cost and all other costs, but the major cost after material cost is the energy cost. That should be considered. If we reduce the energy cost, our production cost will be minimized, and we should compare worldwide more effectively. In literature, it had been found that every specific electrical use and specific energy use, that we are also saying that key performance indicator is 0.17 kilowatt hour per piece and 0.78 megajoule per piece. is the thermal the electrical energy use. That is the key performance indicator for textile industry worldwide. Through automation, it is we see in most of studies that through automation we can save cost, but through automation we can save cost, but labor cost can be saved, but energy cost will be maximized in this sector. Okay, final energy use in the US textile manufacturing industry is 39% of electricity and 61% of fuel, according to our literature study. And textile industry is the 5th major consumer of steam within the world. The final consumption of the textile energy has been recorded doubled from the 47 exajoule per year to 90 exajoule within the span of about 30 to 35 years. We have jumped about doubled in the energy consumption in textile industry as the population of the world is increasing and the textile demand is increasing. So we have seen that the energy energy consumption is also increasing in this sector. Okay, now we will study the methodology, that how we conduct our research and how we conduct the study. There are 5 steps we are considering in this research that are survey of energy audits. We have energy audits of 12 industries within the Pakistan scenario that are ranging from Balochistan to Punjab and some other sectors. The other part is a summary of significant ECMs. Third part is regarding the classification of the result energy conservation measures as economical, technical, and marketable. As you have also seen this part as in the slides of Dr. Irfan Saab, and I will explain it further in my coming slides, inshallah. The fourth part is the energy efficiency resource assessment, and the fourth part is the identification of energy saved and returned to the natural grid. Okay. Energy audit is the first step towards energy efficiency resource assessment. If we cannot measure, we cannot assess this energy efficiency, that how to calculate this. For energy audits ranging from walkthrough audits to the energy audit reporting. The first step is the walkthrough audits, then the detailed audit, and in last we have a detailed energy audit report comprising of significant energy uses, key performance indicator, and all these listings. We have considered some special measures, that is energy performance indicators, energy baseline, and significant energy uses in energy audit reporting. 12 energy audits we have taken in Pakistan, and there are some international studies and national studies which are based upon which are we are basing on our research. The second part is the summary of significant ECMs. From the study of international and national researches and the energy audit of 12 industries, there are more than 200 ECMs, but we have scrutinized about 18 ECMs that we will study, and we will take into consideration this, that how it affects the whole textile industry and the whole energy of this sector. We have the calculation in both megawatt hour and ton of oil equivalent, and we will show that how in energy conservation is measured affect each industry, and how it affect its combined effect on all industries. We will also see in next slide that overall energy saving of all industry with their production data in percentage saving and financial savings of all the 12 industries. Energy savings, energy consumption, production of each spinning, weaving, and composite textile sector, And also we have the extrapolation of our results on the ACTEMA members, all Pakistan Textile Member Associations, that how it will affect the all ACTEMA members if how it will affect that if all ACTEMA members take into consideration these ECMs and implement these ECM and how it affects the Pakistan national grid and Pakistan energy mix. The third part is about the classification of ACMs as technical, economical, and marketable. Basically, our report or our research is based on the Navigant report of Energy Efficiency Resource Assessment Oregon state, that how they implement their energy saving measures in different sector, building and industries. Here in this part, we will identify the potential energy conservation measure in textile industries. Scrutinized about 200 energy conservation measures, as I have said prior, that from 200 energy conservation measures, we have scrutinized is to 10 measures on which we will apply the economical, technical, and marketable filters based on Navigant report. Okay, several ECM load calculated found to have limited applicability in Pakistan scenario, so we have filter out that. The filter will be applied on these 10 ECMs that how it will be economical viable, how it will be technical viable, and how it will be marketable in Pakistan scenario. Okay, if we consider the ECMs as economical, technical, and marketable, and if we are filtering these, first filter we are applying is the technically feasible. Technically feasible means that if we consider an ECM, we will see that how it is technically feasible. Most of time we see that ECM is technically feasible in energy efficiency scenario, but in energy production scenario, in company production scenario, it is not technically feasible, so we will filter it out. So the first filter, and also we see that how it is, what are its benefits, what are its costs, and how it affects the overall company. In next slides, we will take into detail these. Marketable, that how it is achievable, how it is available in the Pakistan scenario market. In Pakistan scenario, it is available or it is viable in the Pakistan scenario or not, and economically feasible, or we see that is it economically viable, financially viable, to consider this ECM as in our industry or not. First, we will take into consideration as technically feasible, the most complex and flexible part of this analysis. As I have told prior, that most of the time it is energy efficient in the perspective of energy efficiency, but it is not feasible in the sense of production for that facility, so we filter out that ECM. Also, it depends on the locality, area, or other measure that the environment of that factory and other scenarios. We further classify it into two categories, that how we will consider it the ECM technical feasible. There are two categories. We consider that either ECMs is ROB, replace on burnout, RET, retrofit, or new. And the second category is to identify it that what are its benefits, what are its risks, and what are constraints in these ECM. This means that if we apply this ECM, that what benefits will it give to the utility and to the company itself, and what are its risks in that scenario. and what are constraints in Pakistan scenario in the in local scenario, and in last, our final decision will be on that benefit versus risk condition that either mostly it affect it in benefit scenario or in risk. Okay, the second filter we are applying in this filtering is the marketable. According to Northwest Power and Conservation Council, USA, 85% of the technically analyzed ECM are achievable. If we consider 100 ECMs, 85 of them are considered as marketable. This is the short way to consider ECM as a marketable. However, the analysis can be based on three criteria. Surveying different textile industries to assure the applicability of Meyer in the local market, that we survey different textile industries in industrial sector and manually surveying them, manually asking them that either we implement this ECM and this is beneficial to you or not. The second is demand need analysis of the industry for the given ECM. This means that either industries are in need of this ECM or not. How is their demand? How is their need according to this ECM? And the third word is we search the keyword selection, search engine through search engine optimization. That how if we, for example, if our ECM is about energy efficient motors, then we, in Pakistan scenario, we will search through the keyword selection that how many people in different search engines like Bing, Google, Amazon, that how many people search it from industrial sector. Through this, also we can market apply this filter. And the fourth, and the third, and the most important part is that the marketing 4 Ps: price, product, promotion, and place. These are marketing 4 Ps which we will consider for applying the ECM. If an ECM is feasible according to these 4 Ps, then the ECM is marketable. Okay, this is the most important part and the last part of the filtering the ECMs and scrutinize the ECM. This is economically feasible. For economically feasible, we generally and mostly we apply 2 filters. That is based on pure economical calculations and based on energy economical calculations. For pure economical calculation, we take into consideration of the net present value, internal rate of return, return on investment, annualized return on investment, simple payback, discount payback. There are also some other measures, benefit to cost ratio, equivalent annual NBT, and some other measures we can consider to apply ECM. We have applied these measures in our result. We can which we will see in our next slides. Okay, the next category in the economic calculation is the energy economic calculation based on pure energy economic calculation. There are 2 energy economic calculation categories. We have the total resource cost test and the levelized cost of saved energy. For levelized cost, there is also a tool. We have, although we have calculate the levelized cost of energy manually in our results, but for levelized cost of energy, there's also a tool provided by National Renewable Energy Laboratory, USDOE. You can also use this tool to calculate the LCOE. Okay, what is the total resource cost? Total resource cost means that you have measured the net cost of a demand side management program as a resource option based on the total cost of the program, including both participant and utility cost. Basically, this test is about that how, if you apply an ECM, then how it is beneficial to you, and how much cost is cost is required on implementing it. And this is the one of the important energy economic calculation, while we have considered alternating fuels and implementing energy efficiency calculation. This is the most one of the most important measure we have applied. For calculation and evaluation of total resource cost, there are two methods we are applying. There are also the third method, but we have shown the two methods here. NPV method, net present value method, and the benefit to cost ratio method. BCR means benefit to cost ratio method. NPV method, in this method, there is the formula, but I will jump to the next section, that when NPV is greater than 0, then the program is beneficial. Means that if the benefit is greater than cost, if we see on the left side, BTRC, benefit to cost ratio for NPV, and cost TRC, benefit total resource cost minus cost total resource cost test. If the benefit is greater than cost, then NPV is greater than 0 and the program is beneficial, and vice versa is not beneficial. And the benefit cost ratio method, and this is the ratio of the benefit and the cost. When this ratio is greater than 1, then the program is beneficial, and in vice versa, the program is not beneficial. If NPV is greater than 0 or BCR is greater than 1, then we should implement that program, and it will be beneficial in our future. And if this is not, then this is not beneficial. The second part, the second category in the energy economic calculation is the levelized cost of energy. Actually, we have seen that some of people say that solar is the best energy, or we should build more and more dams. But to consider that which energy is the most efficient and the most cost effective, we should take into consideration this levelized cost of energy. It considers the measured life cost divided by energy production, that how many costs we have applied, and construction cost, operation and maintenance cost, how we applied to this energy conservation measure, and how it will give the output of energy to us. On the left side, if we see that there is initial cost and annual expenses is equal to $125, and it produces 1,000 kilowatt. This means that, and the results is 0.125 per kilowatt hour. It means that by applying these measures for the 1 kilowatt hour is we have considered 0.125 cents is equal to 1 kilowatt hour is equal to 1.25 cents. Allow the comparison of different technology. We can compare different technologies in this category of energy calculation, such as we can compare wind, solar, natural gas, that which of the energy alternative is the most cost effective. We can see this, that energy efficiency is the most cost effective, ranging from $0 to $50, and all other alternatives of energy, that is conventional or non-conventional energies, all are very costly with respect to the energy efficiency. Okay. Impact of energy efficiency in textile sector of Pakistan. This is the third part of our research. Okay, as I have told prior that we have 18 energy conservation measures implemented in 12 of our factories. These factories we have audited in Pakistan scenario, and these are 15 energy conservation measures, and this is their effect on each industry, that how power distribution system line loss, if we consider line losses reduction ECM, power distribution system ECM, we will 550, we will have in first industry we will have a 551 megawatt year, 551 megawatt hour per year saving of energy, and we have the combined effect of 12,379 megawatt hour. And we can see all of these 14 ECMs, that how it affect each industry and how it combinedly affect all industries. So it is the general overview about that. This is the graphical presentation that how an ECM affected the industries, all the industries. If you see that the waste heat recovery boiler has the major chunk of this energy efficient, the energy saving measures of 18045 megawatt hour per year of savings per year in these 12 industries of Pakistan we have audited, and all others are you can see this. Okay, as we have seen that as I have told prior that there are there were 200 measures from the international studies, and within Pakistan national-wide studies and our energy audited industry studies, we have within 200 industry, we have scrutinized 10 of the ECNs and applying filter on this. As technically viable, we have the two filter, we have skipped the two filters, and we are relying this on the here we are relying on the financial viability. This we can see the levelized cost of a measure, and we can see that installing a variable frequency drive machine is $0.05 per kilowatt hour. Means that 5 cents per kilowatt hour. It means that please can you mute your mic? Okay, it means that if we install the VFD on a machine, then the each kilowatt hour is about 5 cents we will produce by implementing these schemes. This is the general overview, and we can see this, the energy savings from this ECM, energy saving, financial savings, capital cost on that ECM, and the levelized cost. Okay, total resource cost. If we see the total resource cost, then we see that the last three columns, we see that the total resource cost according to the benefit cost ratio and according to the net present value, we see that the first, fourth, fifth, seventh, eighth, and ninth ECMs are viable, because this is in NPV scenario, it is greater than 0, and in benefit cost ratio, it is greater than 1. So I have, as I have told earlier, that if the total cost ratio, resource cost is greater than 1, we will consider it as viable and we should implement it. Okay, there are some measures from industries we have audited in Pakistan, that energy consumption, energy saving, percentage savings. There are some spinning mills, weaving mills, and finishing mills. So we have considered energy consumption in third column, we have seen the energy consumption of that industry. After that, we can see the energy savings and percentage savings. We are seeing that how percentage savings are the industries can save if they implement the ECMs in their facilities. Okay, this is the energy consumption for all. Okay. This is the Sankey diagram from the energy conservation measures we have applied. Energy supplied to the energy savings. If we from the leftmost, we see that energy supplied is 407,884 megawatt hour. This energy supplied, this is the energy supplied to these 12 industries and distributed among these 12 industries. And these 12 industries now use this, that we can see the green line is about, we can see this green line is about the energy that this energy, they is efficiently using this energy. And this chunk of energy they are losing for all industry, we see this. After analysis of these all, we are seeing that 31.2% of energy means that 1/3 of energy we are losing in textile industries of Pakistan. This table is about key performance indicators of all the mills and we have audited. We see that the annual production of that mill in tons per hour and million meters for spinning mills 1 to 5th. This is in tons per hour from 6 to 12. This is million meter per hour, because from 6 to 10 that are weaving mill, and 11, 12 or the composite mill that are also in meters per year, million meters per year. So if there is energy consumption, there are energy savings, and this is the key performance indicators that how they in my last lecture I have said that what are the key performance indicators, that how they are using electricity or gas, that how they are using energy with respect to their production. We can see that how they are using energy, and we can compare this with the overall the world. Okay, we have in this section, this is the most important section of our results. In this section, we have extrapolated our results on the all APTEMA members, all Pakistan Textile Mills Association members only, as we should be in our consideration that there are many other mills that are not listed in the APTEMA. So these studies or this research is about the APTEMA members only. If APTEMA members only apply or implement these ECMs, this much of saving we will have in the end. From APTEMA, we have spinning 315 spinning mills, 44 weaving, and 37 composite mills. There are total 396 mills of APTEMA members. Our energy savings for each spinning mill is this much, for weaving this much. This much of saving is for our designated sector, that is spinning, weaving, and composite. Total energy saving, as we have extrapolated in the manner that we have categorized the industries, textile industries, into three categories. That either it is a small industries according to its production, either it is the medium-sized industry, or it is a large-sized industries. According to this categorization, we have extrapolated our results on this APTEMA member, and in our results we have seen that there is this much of saving, means that 34,000 gigawatt hour savings per year we can this much of saving we can get if we apply ECMs, these ECMs in our consideration. Total power savings is the 566.7 megawatt hour savings we have if we apply this ECM, and total financial saving is 425 million. With environmental perspective, we have this much carbon, tons of carbon will be reduced if we implement these ECMs in the textile industry of Pakistan. This is the total energy saving in textile mills. We can see that how they are saving. Okay, this is the last slide. This is the total resource. Power saving in the last slide, we see that the 56.7 megawatt hour is the power saving. While in Pakistan scenario from the power system statistics of 2018 from NTDC studies, National Transmission and Dispatch Centers Company studies, it is stated that transmission distribution losses Pakistan is 20.6%. 2.3% in this is transmission losses, and 18.3% is according to 2018, 18.3% of their distribution losses. If we consider these losses and we on generation side, we will have the generation capacity. If we apply the SEM and add these losses, we will have a saving of 683 megawatt year per saving. If we consider the Sahiwal power plant, the capacity is 1320 megawatt, and its construction cost is 180 billion. This means that if we apply this, this is our resource is about one half of this Sahiwal power plant. This means that $0.9 billion we can save per year if we implement the ECMs in only Actima member textile industry. This is the huge savings in Pakistan scenario in our import bills and in our indigenous, and it is very beneficial to our indigenous resources as well. Thank you, all of you.
Thank you, Engineer Faiz, for your very interesting work on the energy efficiency resource assessment of textile industry. And we'll also request SMIDA and other government bodies to take up these figures so that we can start implementing this and a country like Pakistan can start saving energy. Okay, I'll request you to unshare your slides, please, and we'll go for the question answer session. So for the question answer session, please raise your hand and accordingly we'll take questions. I think, okay, there's one question from Junaid Tahir Saab. Junaid Tahir Saab, please unmute your mic and please go ahead.
So a very good presentation. I just, based on the last few slides, I just wanted to ask that since there's such a healthy saving potential of about 30%, what is the barrier that, is this an awareness barrier that, that is being faced to realize this opportunity? Because obviously the textile companies and other companies keep complaining about the power costs. But if they do this, they are saving about 1/3 of their power cost within no time.
Yes, yes. When we are auditing this textile industry, we see that the major barrier from implementing these SCMs is the unawareness from their top management. In our traditional language, we can call them SETs of these industries. And the owner, because they are not aware of that, the implementing ECMs, and they oftenly they buy the inefficient equipment in local markets, and they consider that we have saved the capital amount. So this is the major barrier.
Okay, thanks.
Yes, thank you, Junaid Saab. Any further questions? Any more questions? Okay, I'm not able to see any more questions. So I'll request to Smida to close the session. Anybody from Smida?
Yes, I'm listening to you, Shiron. So on behalf of SMID, I would like to thank everyone for their precious time that they attended today's sessions. It was a very fruitful discussion over here, and all the training session was very fruitful. Once again, I'm thankful to Dr. Saab and his team and for